Hi, I'm Augie Gonzalez, Director of Technical Marketing for DataCore Software out of beautiful Fort Lauderdale, Florida. Glad you could join us this afternoon or this morning, or maybe for some of you, I see it's very late in the evening. Today, you're going to learn a little bit about an affordable software-defined solution for really tailored to small to mid-sized SANs and compact hyperconverged infrastructure configurations. We call this the SANsymphony Business or BZ Edition. It provides high availability and low latency for block storage with a great deal of flexibility. So we'll walk through that in some measure. The presentation is being recorded, and we will be providing handouts of the slides after sessions. Again, I'm really excited to have all of you here. Some of you know a bit about SANsymphony, and maybe you really just want to learn a little bit about this new edition, but I'll cover all the bases. In particular, what we're trying to address for you are the disruptions that usually come from things outside of your control, often storage-related outages. We're also, with this particular edition, very much considerate of the rising cost and the difficulties that come from essentially silos of storage and how we can put those assets to use a little bit differently. As a central theme of everything that DataCore does in the software-defined storage area, we're very much focused on reducing the latency that applications experience due to I/O bottlenecks. So you'll see that as a key theme, and obviously trying to meet the expectations that people have for you, even though the budgets may be a bit abbreviated from what you would really prefer. Today, we'll go through a general look at the SANsymphony product in terms of its capabilities, and then we'll dive down into the BZ edition, isolate what its subset of features that it brings to the party. If you have any questions, there is a question panel for you that you can include anything there. If we cannot answer it during the session, then we'll go ahead and provide additional follow-up after the fact. Yeah, one of the things that we want to talk about is pricing and licensing. Obviously, anything has to do with cost, and so I'll be giving you manufacturers suggested retail price for this. Let's talk about how you can upgrade beyond BZ. We'll feature some of the use cases and deployment options you have and the benefits that you can derive from that. As time permits, we'll get into the theory of operation. This will be a more technical part of the conversation. And for you who are already real familiar with how the product works, that may not be as new to you, but it might bring out some new areas that might interest you nevertheless. And then throughout the program, I'll field questions, so don't be shy. The SANsymphony software, in effect, operates as a layer. So think of it as a set of virtualization and software-defined storage software content that sits between the applications, the operating system, hypervisors, and the block storage underneath. So this layer allows us to pool and aggregate different types of SANs behind us and physical storage, whether it's direct attached or internal to the system, and also create tiers. So part of the illustration here is the ability to distinguish between workloads that require very high performance versus those that really could do with relatively inexpensive high density capacity and anything in between. And we'll walk through that a bit. We're also very much interested in providing redundancy through things like synchronous mirroring and the ability, obviously, to create snapshots in time of places to be able to restore back to, should we run into any logic errors or anything like that that we need to restore. We'll get into some of the deployment models as well. One of the really cool aspects of the DataCore software line is its ability to basically morph between these different models. The most recognized, I would say, scenario for DataCore has been where the software sits as a layer above existing SANs, existing array controllers, let's say from Dell, Pure, IBM, Hitachi, any of those suppliers. And despite the diversity that you may have in your own scenario, be able to create a pool from those and treat them as if they were a uniform set of resources, but of different classes, class 1, tier 2, tier 3. So that's this left-hand case under the storage virtualization banner. A second deployment model that's becoming much more popular is where essentially the collapsing of this bottom layer and that storage becomes internal. So some of these equipment come off lease or they're retired, decommissioned. You start to substitute internal SSD drives and NVMe drives, for example, in the system to take their place. And the DataCore software is performing the data services. And I'll walk you through what those data services are, both for the all-inclusive EN edition as well as for the BZ edition. And then the next step down in chunking or reducing the complexity of the system would be a hyperconverged environment, as shown here. So you could almost think of this as the life cycle of going from a 3-tier SAN to kind of a 2-tier converged environment down to a full HCI scenario, where not only is the storage being provided by these nodes, but they're also responsible for the virtual machines hosting the applications. And those typically run as a cluster, like a ESXi cluster from VMware or a Hyper-V cluster from Microsoft. That would be the hypervisor of choice in many of these scenarios. The idea is to consolidate a lot of those functions in a really tight footprint. We also see variation. So these are the hybrid case, the far right. In that case, we may be in the thick of making this transition, or we've perhaps some of our customers have run into an acquisition of another company or another branch, or let's say in the healthcare space, we see it with some clinics and facilities like that being acquired. And there's a combination of these where there's an existing SAN arrays along with the collapsed virtual SAN. From the provisioning standpoint, from the operation of this, it all looks the same. That's part of the beauty of DataCore. All of these models look and feel the same as you're administering the environment, as you're controlling the data services. Now we have 3 editions in the SANsymphony product line. This is part of our block storage offering. DataCore also offers a global file system and a vFilo product, and I'll leave that for another webinar, as well as our massively scalable object storage software called Swarm. So in the SANsymphony line, the leftmost one, Enterprise Edition, has all the bells and whistles. It's really has the richest feature set and the highest performance. So it deals with a wide range of requirements. The middle one here is the Standard Edition. That is often the choice for mid-range requirements. Now we've introducing this BZ edition, or BZ, depending on which part of the country you're from. And that is really tailored for very small, and by small I mean in the 10 to 38 terabytes. It's not really that small, but small to medium, with very high performance requirements and high availability needs. Let's distinguish those from a feature standpoint. So the EN edition, the all-in, all-inclusive, provides connectivity to physical machines, virtual machines, as well as containers through a CSI or container storage interface. We have 2 access methods in terms of fiber channel. FC stands for fiber channel, iSCSI as the other. So those are the 2 SAN connections, whether they're external SANs outright, or in the hyperconverged space, they may be internal behind almost like a loopback. It's you see the set of data services. They range from auto tiering, continuous data protection, which we abbreviate as CDP, sync mirroring, all of these. And what I'll do is I'll contrast what that brings compared to the BZ edition. accompanying these data services, and data services basically are a way to enrich the value of the underlying storage, whether that storage is semi-intelligent or whether it's relatively dumb in the sense that it's just plain old peripheral. These enhance the functionality, enhance the availability and performance. That's what they're intended to do here. On either side that you see in amber are the operational tools you have for provisioning, for migrating non-disruptively between systems, the charting and analytic packages that are available, as well as the orchestration elements. On the far right here, we've got the ways that you actually control the system through whether that's the console user interface, the traditional management console, or if you're into more of the automation part, where you can use either the REST API or a complete list of PowerShell commandlets. We also offer plugins, for example, for VMware or vSphere. You'll see in some scenarios that we do also provide a front end using the Windows server to provide NFS and SMB access, but more likely those would happen as a NAS head sitting in front of SANsymphony Edition. And if you really have a large scale file system requirement, then you would be looking at our vFilo product. But again, that's for another day. On the BZ part, what you see here is some of these are grayed out. So what we said is, okay, what are the essential capabilities that one needs to address these smaller, more modest scenarios and provide a very attractive price for that? So we focus on the auto tiering, the caching, load balancing, things like parallel I/O in a more modest way, as well as snapshots, synchronous mirroring, storage pooling, and then provisioning. And no changes in here on the operation insights or in the command and control. You've got that entire set. So we bounded the capabilities in order to offer it at a lower cost. That's essentially what happens here. So from a administration standpoint, it's the same code set throughout here. This is an example of the management console where you have the DataCore servers and the host, whether those hosts are physically external hosts or whether they're VMs that are in the hypervisor sharing the same physical machine. And this is an example. If we have a little more time, I may drop into a live demo as well, but we'll see how well we juggle the 1 hour. But at least you get a quick taste for how you manage this. Companion to the management console are our DataCore Insight services. This is DIS is the abbreviation we use it. And this is our SaaS portal that provides a cloud-based machine learning and artificial intelligence based on telemetry that's receiving from your SANsymphony nodes. So when you run on the BZ edition on, let's say, a pair of DataCore nodes, it's going to be sending back machine information saying, here's my health, here's what I'm running into, any glitches that I'm running into, and here's the state of the performance behavior, performance profile of what I'm seeing. And we can then assess externally from that and provide some hints using the artificial intelligence built into the recommendation engines to provide some suggestions on what you might want to do better. Here we can provide some predictive analytics as well that indicate so based on the rate of consumption of capacity, we expect that you will exhaust your resources perhaps in 3.5 months. So take action now to preclude that from being a limiter in the future. There are also actionable insights based on things that we see. Perhaps you have resources that are going unused, but they're being tied up, and you could better apply them, or maybe reclaim them for other purposes, and we'll give you hints on that as well. So it's basically kind of looking over your shoulder in one sense, in a positive way, to say there's better ways to take advantage of assets that you're investing in. And we are learning that from looking at the collective pool of DataCore customers throughout the world, we've learned some things from that. We regularly learn from that to indicate where the best practices have the strongest impact, and where we can see indication of potential trouble and head those off early. So this is a really important part, is kind of detect early warnings of that before they start to hit you. And also give you visibility across sites. So if you have multiple instances of DataCore software, SANsymphony sites, for example, that are dealing with branch offices or manufacturing cells that be in different places. In the hospitality space, we see it in different hotels, et cetera, that are being used. You can have kind of a broad collective view of that. And that's going to get you, first of all, prevent problems, but it's also when there are things that go left on you or sideways, you might get a quicker resolution. So it helps you, helps us, and it helps our partners who are servicing you as well. Now we have a number of use cases that we classically see for the BZ edition. There's 4 that I'll feature here today. One is for a very compact data center. And data center is, you don't usually have the impression that this is some large building full of machines all over, but it can be a very trivial, very small lockdown environment at a remote site, for example. And in some cases, it may be just what you need. So a small to mid-sized business simply needs a couple of these nodes really for redundancy, and there's plenty of horsepower here to do that. And so DataCore software is essentially running as a member of the native host that's standing up several virtual machines for, let's say, SQL Server, maybe running the billing, the finance, and specific applications. Second use case is the virtual desktop infrastructure, where we're basically hosting a number of VDI instances that provide remote access to these central applications instead of having to farm out those applications to each person's laptop or PC. There's also the case where we have a dedicated application cluster. So in the big scheme of things, in a larger data center, you may be using the BZ edition to dedicate resources to just, let's say, a SQL Server redundant cluster for those, possibly, and just throw all the horsepower behind that and make sure that that's cordoned off from the rest of it, from a contention for the power of the machine. And then the last one that is coming more into vogue these days, certainly finding more appeal, both in connected and disconnected states, is the edge and remote office, branch office environment. We see a lot of that in DataCore SANsymphony installations around the world. These include shipborne deployments of SANsymphony, where we have the edge essentially is disconnected while the ship is in transit. Let's say cruise ships, TUI cruises is one example of that. They run pairs of SANsymphony nodes, very compact. One sits in the forward bulkhead of the ship, the other one on the back, and they're synchronously mirrored for high availability. And they provide IT services to that cruise ship while underway. Once they come to port, they will then connect into the mothership, if you will. That's really the main data center, and they will transmit the collection of things that happened during the cruise ship, and as well as load on board from a data standpoint their instructions and preparations for the next trip. And that's how that works. But you also see it in the utility sector. You see this in manufacturing quite a bit, where there are different stations where manufacturing is distributed to, and they use very small configurations, ideally suited for that purpose. So maybe that gives you, just kind of puts you in the frame of what you're doing, and you can see which one of these actually most represents what you're up to. In the hyperconverged world, you have SANsymphony is quite capable of running in different hypervisors. It does run as a VM, and VMware ESXi is among the top choices, as is Microsoft Hyper-V. We do see instances of this software running on Citrix and Oracle hypervisors. One point here is that when we do run in the Microsoft Hyper-V space, we can run not only as a VM, as a virtual machine, but we can also run as in the root partition of that Windows server. What that means is that you are not tying up one of those VMs from a licensing standpoint, so it may further reduce the cost of the system. I want to just put out here for you the hardware prerequisites so you can get an assess for yourself how little it takes to run the SANsymphony code in its slimmest configuration. These are all on our website, so you don't have to write this down or anything. You'll have it obviously as part of the presentation, but those prereqs then get modified according to best practices based on what you're actually trying to do. So if your workload obviously is bigger, beefier, and you've got higher performance expectations, you're going to crank up things like CPU, the memory. Particularly the memory is an important element in any of these configurations because it is at the heart of our caching engine, which we'll talk a little bit about later. In terms of storage interfaces, often the mid-range requirements or the smaller requirements are handled by iSCSI. If you have real latency concerns, then you're using fiber channel host bus adapters. Those would be the recommended. And in some cases, they're not even switched. They're just point-to-point connections that are used to reduce the infrastructure requirements. We also have a software prerequisite. So the SANsymphony software runs on Windows Server, whether that's 2019, 2016, 2012 R2. And the nodes themselves are instances of DataCore. The actual executing data services require either the full installation or they also can run on Windows Core. So that's the main engine. The management console can run on Windows 10, basically PC Windows laptop operating systems. It does require the full installation because it's expecting to do display, mouse, keyboard kinds of functions. So it is the head for these nodes. There's some additional requirements in terms of the .NET framework that's used here. So to pricing, which I'm sure several of you are always curious about right from the outset, these essential SANsymphony capabilities are provided at a very inexpensive price. So the price per terabyte for the SANsymphony DZ in the 1-year term license is $223 is the MSRP per terabyte. The 3-year is $526 per terabyte, and the 5-year is $663. That I'll show you an example. The minimum purchase is 10 terabytes. So we're basically saying you can run anywhere from 10 terabytes to 38 terabytes in this compact package, and that's best bang for your money if your requirements fall on that. And I'll show you a quick example what that looks like. So let's say you're trying to build a 2-node HCI cluster, VMware, ESXi, and you'll want to put 8 terabytes of capacity in each of those nodes, so they're fully redundant, synchronously mirrored between them. So if one fails, the other one takes over, and they're both active. That, with 1-year support, the full-term license runs you under $4,000 US. That's just the software. It does not include the cost of the physical servers, obviously, the physical storage, and any integration services provided by our reseller partners, of which some of you are in attendance today. Glad to have you here, by the way. Generally, SANsymphony comes into play when you're about to kick off a major storage infrastructure project, whether that's in a remote site or in a central site. It's when you're in the thick of refreshing and expanding capacity already in place. Maybe you've been using external SAN arrays and are trying to see how you can pool those and take better advantage of them. They might be diversity. It might be you have maybe some NetApp gear and you're supplementing that with JBODs for additional capacity and you're trying to figure out how you can do tiering across those two. That would be a really good place to put DataCore in the picture. More often than that, we see the customers who've been at one point experience some kind of a major storage related outage, and that triggers them into an enhanced business continuity plan. All of a sudden people are really keen on shoring up their BCDR plan and look to DataCore to help with the storage part of that. Same thing on the consolidation or modernization aspect. So usually it's one or two or more of these that really drive the consumption of SANsymphony software. In the consolidation space, we see it particularly when there is an organization that's going through a lot of mergers and acquisitions, and they're picking up very diverse equipment. We see this in the healthcare space, and particularly these days it's hot. It's a little bit in the financial sector as well. And that's where these small, for example, in the healthcare space where small clinics are being acquired, they become part of a larger medical center in a regional facility, and they are trying to amass their storage infrastructure and tap into what each of these contributes and also make it accessible as a global resource. That's where we use SANsymphony to basically collect all those and aggregate those pools and provide redundancy between them, so that we can, if one site fails, the other one can be the fallback for it and take over gracefully without disruption, which they could not have done when they were just a single entity because they had nowhere to fall back to. And certainly speeding up the applications comes hand in hand with that. So the idea is to have a very cohesive and integrated software strategy for dealing with that software infrastructure, instead of having these as fractured elements or discrete projects that later come back to bite you. It may be the case, and I just want to plant this right from the outset, is that you may start with BZ as your entry point, and you're sitting today in that 10 to 38 terabytes and just a pair of nodes. The moment you start to climb beyond that, you've either chosen to expand just naturally because of growth, or just the necessary, this was an abbreviated scenario as a kind of a pilot, and now you're trying to deploy it full blast. You do have complete option to upgrade to the Enterprise Edition, and that upgrade is super easy and financially very attractive. There's no reinstallation required, and we simply take it as we know you couldn't anticipate that need at day one, but we don't penalize you for doing the upgrade, so we apply the value that you've already spent on the BZ license towards the purchase of the EN license. And what you simply do is you trade in those keys, the BZ keys, and we send you some new EN license keys that turn on the rest of those features and expand the capacity. And these are some of the features that it brings on. So if let's say your pilot was in a contained situation, and now all of a sudden you said, oh, now I want to connect through remote replication for either disaster recovery to a very distant site, or maybe I want to send information from my remote location out to the central data center and keep those two in asynchronous link between them. That is something that might be a good reason to turn on the EN features. Another might be just simply you're exceeding the 38 terabyte limit, you're trying to get in there, or you want to go beyond the 2 nodes. That would be a really good thing to do. Once you go to the EN, you also have the benefit of volume discounts. So the price per terabyte, we have a loyalty program. As you accumulate more capacity, the price per terabyte decreases, and it's a beautiful thing. I find that the phone companies ought to do that for us. They generally don't treat their loyal customers with the same vigor that they do their new customers, and we feel quite differently. We think we ought to reward anybody who's been with us. Some of the key benefits that we'll talk about, just to kind of capture this, what it brings to the business, particularly in its adaptability. So what SANsymphony is basically saying is, we know that there's quite a bit of uncertainty what might be happening in the near future terms of technology changes, in terms of the challenges you're up against this, and how likely it is that equipment you're running today may be having to swap out within a year, 2 years or so. And so how do we make those transitions, and how do we adapt to those different changing scenarios with the most grace? And that's one of the things that we really excel at. The second part of the value prop is very much about uninterrupted business operation. How do we keep data available to you and to your consumers despite the natural churn that occurs in hardware, in sites, and everything else, and speed up the access in doing so? All of this at the same time keeping an eye on cost. How do we reduce the cost and make these transitions all the more simple? So we've just got a few highlights here, especially some of the quotes from specific customers that kind of speak to the value they've gained from SANsymphony. I thought this is a pretty good one. Is the Open Systems gentleman, Ryan, was talking about the benefit they got by not being locked into a single vendor, because with DataCore, as you might have sensed from that original picture, you can swap out the underlying storage and still keep the same behavior, an enduring way to provision resources, to protect those resources, and to keep track of them, as well as take better advantage of them. So as you swap out things, you can pick, you really actually get a little bit more negotiating clout when it comes to purchasing additional equipment, because you're not tied to one particular brand or model. Now, you may prefer that just because that's somebody you trust, and that's absolutely the case, but you definitely have the chance to shop around a little bit more. We've seen these ability to switch out suppliers when things haven't gone so well, and that unfortunately does occur. So we make that super easy. Part of that is our ability to switch out gear underneath without affecting the users is all about the way that we handle redundancy. And we'll show some slides on this in a bit. But at the heart of it is our synchronous mirroring to maintain data in two places. This is what prevents any of those chaotic under things that happen, go dark in the night and everything else, or boop in the night, from affecting you. There's also the ability that the software automatically fails over, as well as resyncs and fails back on its own. So it's all automated. There's no requirement for somebody to be there watching over and having to fumble as they try to move things over to a different machine, to standby machine or anything like that. In fact, some of these customers have been running, I think, 8-10 years without a storage-related hiccup that affected their users. That's quite telling. On the performance side, really, if it was just for performance, that's rarely the one reason you buy things, but it's as a companion to the business continuity. Usually those two together are the two linchpins that cause the choice to favor SANsymphony. We do have a patented adaptive parallel I/O techniques that prevent some of the serialization that happens in other systems. And the caching engine here, where we used DRAM instead of just a flash layer, gives us much faster, lower latency access. So performance gains are quite, you've seen here 10x, 7% of these folks actually saw 10x improvement just by putting DataCore software in front of their existing equipment. And certainly on cost. So part of the whole idea here is you're saving on several fronts. One is, you are extending the life of hardware that normally would come, you'd say, wow, it's long on the tooth, it's done, can't take it anymore. You put DataCore software in, it actually extends that life and reduces the number of instances where you have to go move that equipment out. At the same time, when those do occur and it's time, just, hey, I've had it with this, or the financial value of that storage equipment has been exhausted, you can substitute new gear in place without any downtime. There's a number of functions here. One of the things that we see in customers is they're deferring these hardware refresh cycles. So where they might have been like on a 3-year clip as their traditional one, they now found they can run for 5 years with that same hardware, and the software is compensating for it. It's actually elongating the life of that equipment. So again, I invite you to send any questions that you've got. We'll talk a little bit about the theory of operation. The theory of operation is a more technical part, just to give you an idea. And specifically, I talked a bit about failovers and failback and synchronous mirroring. So just give you a primer on that. At the heart of it, you saw almost every one of those pictures that I presented had 2 nodes. So we generally operate that way, that there's 2 DataCore nodes in the picture, and the BZ edition is always configured this way. It's in the sense that they're both actively doing work. So in this picture, let me just frame it up for you. These would be consumers of the storage where the applications are running, and they think they're talking to disks through a couple of paths, a primary and alternate path. Those disks are actually virtual disks that exist only in the minds of those hosts, but in reality, they are served up by the DataCore SANsymphony node. So this node here, instance 1, is taking responsibility, say, for virtual disk 1, and the second instance is responsible primarily for virtual disk 2, but both can field requests for it. And usually that distance between these nodes can stretch considerably. It may be, and best practice suggests, that you separate them, at least put them in different locations so they're not subject to the same fault conditions. This is all the heart of anything you do, like a stretch cluster. The reason you do stretch clusters is to make sure things are sitting in different fault domains. If one experiences, let's say, a fire outage, or a water spill or something like that from the floor or pipe above it, that the other one instantly can keep running and the applications never see a hit. And these amber lines between them represent the synchronous mirroring. So I'll show you more of the data flow in a second. Some of the best practices that should be common sense, but are not always practiced in real life, is the whole idea of distributing the components. Make sure they're on separate racks, separate rooms, ideally in different buildings, different sites. You may not have that luxury, but certainly shoot for that. Here's a really good one. We have the best practice guide for SANsymphony is part of our published resources, and our partners operate this way, is using uninterruptible power supplies to protect the power and give you a little recovery time when that power glitches, that your system can gracefully handle it and appropriately react, so they can switch off to the others if need be, and that you get enunciation of it. More frequently than I would have expected, we find folks who look at the underlying hardware but fail to take into account the environmental components. They don't realize that, hey, if that air conditioner fails and things start heating up in here, and both of those systems, redundant systems, are sitting in the same location, they both went out. So you've got to watch out for things like this. We've seen lots of incidents of this bursting water pipe right above the same location, where they thought they were providing the separation for different fault isolation, and in fact were subjected to the same environmental hazard. So, a few animations for you on how asynchronous behavior operates. So from an application, let's say a SQL server running on an ESX server, thinks it's talking to a disk, a volume, the B drive, let's say. What the software is going to do, these are 2 DataCore instances down here. and there's multiple paths to them. So in the normal case, an IO flows from that connection. That application writes to the volume, and the one node that it's path to will mirror that in real time between the cache memory here and the cache memory here. And the other one will acknowledge this. I got it, you're good. Now that its data's in two places, I can tell the application, we're good, we've got it locked in, issue your next IO. And this happens all in real time, very high performance. So then after that, the data will be destaged to disk. So we don't pay the penalty of the delay writing to the disk. We can respond quicker than that, but obviously we've kept the data in two places. We've got these UPS protected, so should a power failure hit at this point, we know we've got it covered. We've put it, as in the old term, we put it in oxide already. So if you look at this from a failure situation, now we're introducing the application, the operating system or the hypervisor will have some form of multipath IO. And it is the smarts that basically says, I've got two connections into this disk, this volume. I've got a primary path and an alternate path. If the primary cable were to fail, I'll just reissue the request down the alternate path. So we take advantage of that. Instead of it all going to the same physical disk, they're actually going, the primary path is going to one copy, the alternate path is going to the second one on a separate node in a separate fault domain. So in the case where the application tries to write through the operating system to the node 1, it can't connect with it. The software just says up here, oh, well, let me just try the other cable path. It's probably just the cable got a little loose or something. So it regenerates the IO down here. The application hasn't timed out or anything. The application doesn't know about that. It happens underneath the covers. Application the MPIO driver reissues this, and it has a new alternate path that it goes through, and that writes the information onto this node. This node cannot mirror to this one because this one on the left is out of commission. So what it does is it says, okay, when that happens, what I've got to do is I've got to not only write it, but I'm also going to log the fact that this changed, because I am now starting to get out of sync from where the instance on the left thought I was. So when this guy comes back up on the left, he or she is not going to have the same information that I have. This node 2's got more recent information as represented in the change log. So the application doesn't know any better. The operating system upstairs doesn't know any better. When it's time to restore the system, so we fix the problem that was here, let's say the power outage, we restore power to the side, this one comes back up. What the software will do is say, okay, I got you. Let me just get you resynchronized. So before I put you into full working order, what node 2 will do is it will send the changes that transpired while node 1 was out and bring this one up to date. Once they're both back in sync, then we can restore full strength, as they say in the hockey space. And we've got the original conditions where both are active and working that way. Wanted to also spend a couple minutes on auto tiering. Auto tiering is the process by which we can move data to its most appropriate location based on its value. What I mean by that is generally you don't want to tie up really expensive, let's say 3D cross-point cards on things that are fairly dormant, data sets that are relatively dormant and unchanged, things that would be like archive grade or anything like that, because that would be, these are premium resources, premium price resources. You'd rather relegate those things which are no longer, which are basically colder, to something cheaper. And that's what the software is doing, but it's not doing this on a volume basis as you would expect. Most implementations say, okay, I have this entire volume and I've got to decide whether this volume sits on the left side of this picture or on the right side. DataCore can do this at what's known as the sub-LUN level. So SANsymphony is basically carving up the virtual disk into a bunch of sub-blocks, and it looks and it examines how each of those blocks is being hit. So back to our database SQL Server example, that SQL Server database may be hitting certain records quite frequently based on what access is going on. So that would be the red ones. Instead of moving that whole entire SQL Server volume over to the cross-point board here, what we're doing is saying, it's only these particular blocks that need to go there. Some of this other stuff in the SQL database, it's hardly getting touched. So I can actually relegate that to much cheaper storage and use this for the really hot data that deserves it. And the software is regularly doing this. This is something we as individuals, as humans, could not do, because first of all, we don't have visibility to these sub blocks down here, nor could we keep track of it. So, and any choice we made, any decisions we made about data placement would be the wrong decision a few minutes from now. So the software, this is part of the machine learning. The machine learning engine is looking at this. I see what you're doing. I see that you are really hammering these particular blocks, and then tomorrow those blocks might change. These red ones might cool off. They may become more amber in sense of temperature gradients. And so in that case, we're going to want to move those here, and we're going to get the new red blocks firing off inside our precious resource over here. And that's built into the BZ licensing. So you include that. The caching we kind of hit on through this picture, but the essence of it is instead of relying on the speed of the backend disk, we use memory as our primary cache. And that gives us quite a bit of advantage in terms of turnaround time, irrespective of whether you're running SSDs or NVMe flash in the backend, or you're running a slower traditional disk drive, a rusty disk drive. Generally, when it's a very fast performance, really want to turn these around quickly, we recommend fiber channel as your lowest latency connection. And that's true both in the connection between the operating systems of the host here, as well as in the inter-node connection for synchronous mirroring. If the requirements are more modest, then iSCSI will do just fine. So in kind of wrapping up about this, what SANsymphony is helping you do is maintain uninterrupted operations, preventing those storage-related outages from impacting the business, impacting the consumers and users. It's speeding up the response from those applications while lowering the cost. It's also giving you a measure of hardware independence that you would not have enjoyed previously, where if you're relying on specific array controllers or specific HCI appliances that are bolted onto the hardware and cannot be detached from each other, SANsymphony is quite different from that. It gives you the ability to select hardware and swap it out throughout the life cycle and keep the behavior of the operating environment as was before. And certainly it is a means for modernization. So you can do this at your pace rather than somebody governing when it's time to swap out here and then forcing you to do a rip and replace. And then just to conclude here, we really have tailored the BZ edition for small but demanding high availability projects, and that small is marked by the 10 to 38 terabytes. You might say, why not 40, why not 30? That was a number we chose. We seemed to see that as a good line of demarcation. And as you can see here, you could do a pretty nice configuration, all with synchronous mirroring, all transparent, DRAM caching and everything else, just for the software 2-node configuration for 10 terabytes for $2,230. That again is MSRP. So it really is an inexpensive and a super simple entry into software-defined storage. And that's the essence of it. If you don't know much about DataCore, we've been around for over 20 years. And I've been here for some part of that, enjoyed part of that history with us. We have over 10,000 customers across the globe, a rich number of customers, particularly in EMEA and the Europe sector, as well as in Asia Pacific, and obviously in North America. Most of these customers who've been with us some time have taken that software through numerous technology waves, and we're experiencing one now, and we'll experience one a year and a half from now, and that they've been able to traverse those technology transitions very, very smoothly as a result of running this layer on top of their storage. Got huge satisfaction rates from our customers, and great renewals, is one indication of that. So in one way, we've kind of selfishly call ourselves the authority on software-defined storage, but you need to be the judge of that. Just to cap it for you, some things to do after you're done here today is have a look at the SANsymphony product webpage. That will give you a lot more details on those features, each one of those features that I was pointing out that we had only a few minutes to talk through. The online help also will give you a little more hands-on. Here's how each of those features is operated, the dials and options you have available. And particularly for prospective partners who are thinking of selling SANsymphony as part of your portfolio and bringing that in front of your customers, we've got some really good best practice guidelines, both for external connections and the traditional storage virtualization deployment, as well as for the HCI configuration. And I invite you to do, as a next step, is take our deeper dive, our technical product tour, so you can schedule one of those right from our website. With that, I think haven't seen any additional questions come through that we haven't answered in here. I did want to just close out by letting you know that while we have concentrated today on our SANsymphony software for really SANs and hyperconverged environments using a block storage methodology, DataCore also offers, it's kind of like the trifecta of capabilities. The vFilo product provides a global file system for scale-out NAS, if that's maybe an adjacent requirement along with your block storage. And we've recently acquired Caringo, that now forms the object storage part of our portfolio with the Swarm software, and that helps you create basically your own private cloud of massively scalable object storage that's accessible through the S3 protocol. So that we will have invite you to other webinars where we can talk about some of those. And with that, I appreciate your being with us, and we will be sending out the presentations as we reach back to you. Thank you, and have a great rest of your day. Bye-bye.